prime large number. It's generated random. Right? Then, using this function, we should find k. K is a point and is a public key. Okay. To know how to calculate this equation, k times g means that you must and if this is the tangent line and this is the g, k multiplied by g means g plus g plus g plus g k times g plus g plus g. To calculate g plus g, we should draw a tangent line. As I said, in Arabic it's called, I think, mamas. Okay, we should draw this tangent line from point G to calculate g plus g. How? See here. See here, this is g, then we draw tangent line to cut the curve in a point like this. This is then reflection on the x-axis. This is g plus g. Again, drawing a tangent line from g plus g, we find another point, reflection on the x-axis. We find g plus g plus g plus g, 4 times g. Okay, if I can find k times g, then it means that I can find the answer of this equation, and I can find this big K. This is the public key. This is the public key. Hashing of this public key will be our Bitcoin address. So you can read this part to understand how it works. If you don't know what's this algebra, what's this math behind this approach, don't worry, it's not important. But you must understand that in this approach, G is a fixed constant point in the curve. K, which is the private key, is a random large prime number, and using this equation, the public key can be created. Okay, and here you can read how Bitcoin addresses are generated from that public key. 2 times hashing with these 2 algorithms, SHA-256 and write MD160, will generate a public key. Okay, so you can read these 10 pages from 62 till, I think it's enough, 72 to understand what's public and private keys in Bitcoin and in elliptical curve. Okay, so in Bitcoin and many other cryptocurrencies, elliptical curve is used because it's more strong than other approaches. Okay, especially RSA. In cryptocurrencies, we don't need encryption, decryption. In cryptocurrencies, like Bitcoin, like Ethereum, we don't need encryption, decryption, like what you performed on the RSA. In in cryptocurrencies, we don't need encryption, decryption. We just need digital signatures. What was digital signatures? Digital signature, suppose that I have a message. Okay, I have a message. I'm talking about digital signatures. Suppose that I have a message. If I encrypt this message with my private key, for example, I'm Bob, private key dot encrypt M. This is called digital signature. Why? Because everybody knows what is pub key of Bob. As I said, in all approaches, everybody knows others' public key. So everybody can decrypt this message using Bob public key can encrypt this message, and it must be equal to M. This is called digital signature. Why it's digital signature? Because the only person that have the private key is Bob. So if Bob encrypt a message with his private key, in fact, it's something like that. He's signing the message. It's used for authentication. This is used just for being sure about, okay, that the sender is Bob. For example, I want to create a transaction and I want to pay 1 Bitcoin to someone. To show that it's me that I'm spending this money, I must put my digital signature behind this transaction. So others, by checking my signature here, can be sure that it's me. Yes, encryption with private key is called digital signature. In fact, it's not encryption. Because everybody has, when Bob encrypt a message with his private key, since everybody has his public key, so everybody can decrypt this message, and so it's not encryption. But what's the application of this method? The application is proving that the sender is Bob. For example, suppose that Bob have 5 Bitcoin. I cannot spend some Bitcoin behind of Bob. Why? Because I don't have the private key of Bob. Bob has a private key. Bob, when wants to send some money to others, put his private key here. So others using his public key can verify it and can be sure that, okay, the sender is right, the sender is Bob, not another person. The only thing that I must show you is the related code of elliptical curve in Python. No. Private key is not digital signature. Public key is used to create digital signature. Private key is used to create digital signature. me find the related Python code. EC. Okay. EC is better, is stronger than RSA, yes, and that is the reason that in Bitcoin EC is used, not RSA. Okay, see here, this library, using this library, you can generate public and private key in Python for based on the ECC algorithm. So you can generate public and private key, and you can sign a message and you can verify a signature. In this library, encryption and decryption doesn't exist. So you can use this library. We need serialization. If we need a DER format, so we should import load DER private key. If we need PM, we need load PM private key like RSA. This library EC contains the necessary classes to support elliptical curve cryptography. Okay. Using this command, EC dot generate private key with these parameters, with these two parameters, simply you can create a private key. Alice. Now Alice is an object, a private key object, a private key which is generated using elliptical curve. Not a number of point. In fact, what's make the elliptical curve strong is that logarithmic problem. The equation is big K is equal to small k multiplied by G. Having a small k and having big G, G is a point, K is a large prime number. It's not difficult. You can find this big key, which is the private key, which is the public key. But having the big key and having big G, it's not possible to find a small k. Okay, it's not possible, and this makes the ECC very strong. So using public key, nobody can guess what's the private key. Okay. Now using this command, we have a private key based on the elliptical curve. Using this command, like before, like RSA, you can convert and you can serialize this private key as a PEM standard. Then here I have printed out this private key. To generate public key from public key, you can use this command, public key equals to this private key dot public key. So this command generates the public key associated with this private key. Again, using this command, we serialize the public key and I print out the public key in PEM format. So you can ignore this part. So if I run this program, this is the private key and this is the public key. Okay. Now to sign and verify, let me find the associated code. Just a second, please. Use this command. Okay, copy and paste it here. I will explain what's this. This is for signing. For verify we use this to the PK and we use this command. Okay. Now suppose that I want to sign a message. Data equal, this is my signature, or every other message you want to sign. It must be of type byte. Okay. This must be, it must be a private key, an object. So Alice was our private key, as you can see here. So Alice signed data with this parameter, creates a signature. Let's make comment this and then print signature dot hex. The library sorry, just a second, I will come back very soon. Sorry. This is our signature. I can put a print here. This is digital signature. So to sign a message, this is my data or this is my message, and using this command I put the data here. This is a fixed parameter, so you can sign and create digital signature. Now to verify this digital signature, I should use the public key associated with this private key. So using PK public key verify signature and data, I can check it. Nothing happened, but if I change something, for example, if I just delete just one character from my data, now see. Oh, sorry, I should use the let me use command like this, bytes for signature, bytes from hex. Okay, I run it. This is the signature, so I copy the signature and I put it here. I don't want to generate the signature again. I use the previous signature. This is the previous signature and this is the data. So if I run it, I have an invalid signature. Data signature. Okay. I copy it again. Put it here. So the command invalid data signature. It should be signature, invalid signature. It should be valid, I think. Public key verify signature data. Now everything is okay. Bytes from hex isn't okay. So public key verify signature data. Invalid signature. Okay. I don't know why this message is shown. The signature is correct, so everything must be okay with this verify command. I must check it. Oh, I understand. I understand. The reason is that each time this public and private key is changed. Okay, so let's fix the problem. Let's fix the problem by cutting this part and moving it to another part. Now I think everything must be okay. So I run it, then I run this part. Okay, this is the digital signature. Okay, I copy it, paste it here. Now I check digital signature. Okay, everything is okay. We don't need this. But if I change a little bit in the message. This is this change just 101 and I write invalid signature. This is called digital signature. In Bitcoin, this is used to prove the authority. For example, if Bob wants to send some money, he must put his digital signature on the transaction to prove that this is Bob, to prove that this money is belonging to Bob. Okay. Now, if you have any question, you can ask again. I don't expect you know the complex mathematics behind the elliptical curve, but the concept of what is digital signature, you must know. We will use it in the next session, in the next lecture, in Bitcoin. Not only in Bitcoin, but also in all other cryptocurrencies. Verify checks that the data and the signatures are the same. Signature is the encryption of the data. I'm answering your questions. Hello. Your answer is that verify checks that signature and data both are the same. Signature must be encryption of the data using the private key. If it's okay, nothing will be shown. But if it's not okay, an error, invalid signature will be shown. Digital signature is necessary not for encryption, for authority, for proving the authority, for showing that it's me, to prove that it's me. Encryption means that we want to hide a message from others. We want to send a message to a person that just that person can read our message. It's encryption. But digital signature is an encrypted message that everybody can read it. So our purpose is not encryption. We don't want to encrypt something. We want to show the authority. We show that the authority of, for example, spending some money. Understand, Muhammad? The message is decrypted with private key. Yes. Since, for example, suppose that the message is no. Message is not decryption, and encryption is another concept. Here we are talking about digital signature. If we encrypt a message by private key, it's called digital signature. But if we encrypt a message with the public key and we decrypt it by the private key, it's called encryption and decryption. Yes, yes. your question is, how can I distinguish that the received message is an encrypted text or a digital signature? Should the sender tell us? Yes, the sender tell us that. For example, suppose that I'm sending some money. This is my message. Suppose that this is my message. Everybody, please note, parenthesis, Wahid, send 2 BTC to Ali. Okay? Suppose that it's a transaction. I want to send 2 Bitcoin to Ali. How others trust me? How others know that this message is really created by Wahid? Maybe someone else pretend is Wahid and make such a fake message. If I, Wahid, sign this message with my private key, this proves that it's me. How? Because all other persons have my public key. Using my public key can decrypt this message and can see this. And this proves, so the only person has my private key is myself, nobody else. And this proves that it's me. Understand? This is digital signature. In cryptocurrencies, in Bitcoin, please note, in Bitcoin, we just have digital signatures. Just we have sign and verify. We don't have encryption and decryption. In cryptocurrencies, we don't have encryption and decryption. We have just sign and verify. What is sign? Sign is encrypting a message with a private key, which is called digital signature. What is verify? Verify is decrypting a signature with a public key, and it must be the same as the message. Understand? I explained the programming just 5 minutes ago. This is the programming part. Here, this part, if I run, this is a private key, this is a public key. Okay? Alice is the private key, and and public key is the public key. So Alice private key, public key is the Alice's public key. Here, this is my data transaction. For example, suppose I okay. This line, this is my data, this is my transaction. I, Wahid, give give Ali 2 Bitcoin. Okay, this is command, this is nothing, this is This command generates digital signature. This command, in fact, encrypt this data using Alice private key. So I print the signature. This is this digital signature. Now I copy the digital signature, I put it here, and this time I verify it. I don't want to create it again. How to verify it? Using public key. Please note, for creating signature I use private key, but for verification I use the public key. Public key was created here in this part. Okay, so public key dot verify. I put the signature here. This is the signature. I put the data here, and this command check. If nothing appear here, it means that everything is okay. But for example, if you change it, suppose that I'm cheating just 1 Bitcoin. Okay, if you change the original message and verify the signature, this is invalid signature. Again, if I correct it and I run the program, everything is okay. And that's it. So I suggest to you read about encryption, decryption, digital signatures, and verification. Pages 62 to pages 72 from that book. What was the name of the book? Mastering Bitcoin. Mastering Bitcoin. There are more explanations about elliptical curve, public and private key. So let's have a review. In cryptocurrencies like Bitcoin, we just need to sign a message and to verify a message. We don't need encryption and decryption. Okay? Even though it's a general concept, using public and private key, you can encrypt, decrypt messages. But we don't use this part in the cryptocurrencies like Bitcoin, Ethereum, and others. We use digital signatures and the verification to prove the authenticity, to prove the authority. When you want to spend some money, you must show that you have this money. You must prove that it's you. Yeah, I will send you the code. I will send you later the code. From next lecture, I will start talking about blockchain. The first concept is transactions. So in the next lecture, I will talk about transactions in Bitcoin and Ethereum. Then I will talk about blocks. Then after that, talking about blockchain. After that, I will talking about proof of work and mining process. And we will go to the end of the semester. Okay, if you have more questions, we have time, you can ask. Otherwise, I think it's enough for today. From next lecture, next week, I will start talking about transactions in Bitcoin and in Ethereum. In each details of transactions, in each cryptocurrency is different from others. There are some general concepts, but in details they are different. So, no more question? Okay, thank you all. See you next week. Bye.